I like to like, let's go one through whatever, but I'm like, oh, can you come back and do number 9? And okay, can you come over here, number 52? And oh, can you come over, right? So let's try to keep it in order. Question. Anybody got any questions out of page number 1? Well, I just don't know if we'll have enough time, guys, right, to do the whole thing. But Isaac said, okay, how do we do number 1? Okay, so let's do number 1. Okay, so look, let's do number 1, guys. If you look at the formula sheet that I gave you, let me see if I can let me see. Here we go. Okay, and I'm going to send this to OneNote also, so that I'll have it over there. Let's just go here. Okay, boom. I don't know if it sent it all the way to the bottom or not. Let me see. Okay. All right. So, guys, if I look at problem number 1, so, oh man, here we go. Problem number 1 is asking me to find the margin of error, right? And look what it tells me. So, if I look at that formula sheet, guys, right? Here we go. I look at that formula sheet right here, and look what it tells me. It says, for a population mean mu, where sigma is known, the margin of error is, and I'm looking at that kind of first piece right here. Okay, so all I'm going to do, guys, I'm going to copy down that formula right here. So I'm going to write down E equals my critical value ZC times sigma divided by N. Okay. All right. So notice what it says. Find the margin of error for critical values of C, sigma, and N. Okay. So we're going to find our ZC. So guys, on that same formula sheet, right? On that same formula sheet that I gave you, if you look, oh yeah, sorry, score root of N. If you look at, let me fix that. There we go. If you look at that formula sheet, guys, that I gave you, if you look at the bottom, do we have one when, let's see, what was our C value here? What was our C? C is 90%? Okay. When C is 90, what's my ZC? 1.645, right? So I'm going to go like this. We're going to go 1.645, okay, times, what's our sigma in this case? 10.2 divided by the square root of our N was, boom, boom. Okay. Go to the calculator. Let's move it this way. Okay, turn it on. 1.645 times 10.2 equals divided by the square root of what number? 75. Okay, enter. All right, so guys, I'll specify how many decimal places, right? But if you look at the answer key, did I go 3 decimal places, 2 decimal places? What did I go to? 2. So did we write 1.94? There you go. Boom. And that's how I came up with that number. I'm giving you that table, right? So this formula sheet that you have right here, Rita, is the same formula sheet you're going to have on Tuesday. Sound good? Yes. Oh yeah, because if you're doing the inverse norm, it would be 1.64. Let me see. Inverse norm, right? And what number are you putting on the inside? 0.0. But let's see. But if it's 90, let me see. Yeah, 0.05, right? 0.05, like that. And okay, so 1.64, right? Okay, so we go 1.64. I'm just curious, like, how much does it affect my answer, right? Yeah, so guys, that's what we call round off error, right? So a little while ago when y'all were taking the quiz, and didn't we come up with like 6.20 or something like that, right? So look, I came up with 1.93, right? Remember, Victor, you were asking me and he said, well, look, I came up with 6.19 on when I did the test. Is it a big deal? It's not a big deal, right? I told Victor, it's like if I owed him $6.20 and I gave him $6.19, I'd hope he'd say like, hey, don't worry about that other penny. You know what I mean? So guys, this kind of thing here, like when I'm, and just to give you a heads up, when you're doing your homework on my math lab, if suppose the answer, I'm going to make this up, suppose the answer you would have typed in 1.93 and somebody else would have typed in 1.94, my math lab is going to take both. They sort of figure that in, right? That, hey, you know what, somebody can be off by 0.001 or 0.01 and things like that, okay? So don't worry so much about that part of it, okay? All right, good deal. Any other questions here? Right, so for 98, so I want you to look at, if you look at the formula sheet down here, right? Look how the formula sheet is given, right? So when we did the 0.90, that means that there's 90% in the middle, right? So wasn't there going to be 5% here and 5% here, right? So if I look at problem number, what is it, number two? Number two, if it's 98%, that means 98% is going to be here. What percent would be on the sides? 1%, right? 0.01. So you would do inverse norm 0.01. Does that make sense? Yeah. Alrighty. Guys, any other questions here on page number 1? Number 4. Okay. So let's take a look. It says a random sample of 40 students has a test score of with X bar equal to 81.5. Assume the population standard deviation is 10.2. Construct the confidence interval for the population mean mu if C is equal to 90. Okay, so guys, it's asking me to find my confidence interval, okay? So let me see. Do we have that here? Yes, we do. So if I look at my formula sheet again, guys, right? If I come back up here, look what it tells me. This is how I'm going to find my confidence interval. I'm going to take X bar minus E and X bar plus E, and it's going to be between those two numbers, right? So let's see. Let's see if we can find the E, okay? So the E is going to be, remember, we just did this in problem number 1, sigma divided by square root of n, okay? So guys, do we already know the critical value when C is 0.90? 1.645, right? It's the one that we did a little while ago. Guys, so again, if you go 1.645, you go 1.64, don't worry, not a big deal. Okay, what's our sigma in this case? 10.2, okay, 10.2. What is my n? 40. Okay. So let's do that. Let's take our calculator. Let's clear this out. We're going to go 1.645, right? Or 64, that's okay. 10.2 equals divided by the square root of, what do we say, 40? All right, so guys, if I go to 2 decimal places, 2.65? Okay. All right, so now what I'm going to do, guys, we're going to make our interval. It's going to be X bar minus the E and X bar plus the E, right? Okay, so what was our X bar in this case anyway? 81.5? So 81.5 minus 2.65 and 81.5, what, plus 2.65? Okay. So we'll write our answer here. Let me see. So 81.5 minus 2.65 and 78.85? Okay. And then if I want to do the other one, guys, on my calculator, remember little shortcuts, can I go second entry and then just change that minus to a what? To a plus. Just little shortcuts. 84.15. Uh-huh. Yeah, and you know what I might have done? Again, it's just going to be a little bit of round-off error, right? So that's all I did, guys. I probably just have a little bit of round-off error there. But let's put it this way. I mean, are we coming up with roughly the same answers? Yeah. Okay. No, that's what I'm saying. So like if you put 78 point, say you put 78.9 and 84.2, you know, I'm not gonna go to your house and tark you on the head. You know what I mean? I want to see that you understand what's going on, right? So guys, remember, don't get so bogged down with like the minor details. But let me ask you a question. Now that we know how to do problem number 1, I know you know how to do number 2, right? Okay, now that we did number 4, you can do number 3 as well? Okay, let me ask you a question. As we're going through this, seem a little bit easier now that we're doing this? I mean, I know it's been a little while. It's been a couple of weeks since we went through it. But my point is, if I'm looking at my formula sheet, do you see how those formulas are there for me? right? That's really the emphasis I'm trying to make. Guys, anything on the second page? Okay, 5 through 10, let's do number 6. Okay, so let's do number 6. Alrighty. So it says, a nurse at a local hospital is interested in estimating the birth weight of infants. How large must a sample be, or how large a sample must she select if she desires to be 99% confident that the true mean is within 4 ounces of the sample mean? And it says the standard deviation of the birth weights is known to be 9 ounces. Okay, guys, let me ask you a question here. Does it tell me anything about the population standard deviation, or does it just say standard deviation? Okay, so I have to assume that this value here, guys, is going to be our S, right? Okay, so let me take a look here. Do we have a formula? Yes, we do. Let me see. Give me one quick second. I'm gonna pause it real quick, guys, because I don't want the video to be. Okay. So, guys, if you look at the formula sheet right here, you see this problem right here? Given a confidence interval margin of error E, the minimum sample size N needed is this part right here. But this has the what? This has it has my error, but doesn't this also have my population standard deviation? Let's see. So hold on, guys. I want to pause it real quick. Okay, so yeah, number 6. Don't worry about it. I didn't even put it on the test. Okay, so I'm gonna go like this. Boom. Nah. Okay. All right. Any other questions? I'm sorry, on that same page, 7 through 10. Number 7. Okay. So now this one's telling me find the value E, the margin of error for. I think I did. Let me double check. Yeah, it's recording. Okay, so find the margin of value, the value E, the margin of error. Okay, so look, I'm going to come back here, margin of error. But look what it's telling me. It's telling me that C is 0.90, N is 16, S is 24. So guys, if I'm sorry, my mistake. Sorry guys. There you go. Okay, so if I look at that same formula sheet, right here. Okay, let me see if I have a margin of error. Here we go. So I'm going to use this formula because what value do we have here? S, right? And if I look at this one, don't I know what S is also? Okay, so guys, if I write down that same formula, right, look what it tells me. It tells me E equals our TC, right? And S divided by the square root of N. Okay, so there's a couple things we need to find. Number 1, we already know that our S is 2.4. So I'm going to put 2.4 right here. We already know that our N is what, 16? So that's going to go right here. The first thing we need to find is we got to find that critical value for TC, right? Okay, so yeah, can I do this? Let me see if I got it somewhere in here. Statistical tables. Okay, and if I scroll down to this one here, right? So guys, what is our C value here? 0.90, right? Okay, so where is it? Here we go. So my C value is 0.90, and what would our degrees freedom be? 15, right? So isn't my TC value here going to be what number? 1.753? Are y'all okay how we're coming up with that? Yes, I'm going to give you the table, guys. So, yes, it would be inverse T, right? And so if I look here, guys, 0.90, right? 1.753. So I'm going to come back over here, 1.753. Okay. And let's see, do we come up with the same numbers? So turn it on. 1.753 times, what do we say, 2.4? Okay. And then divided by the square root of 16, which I already know is 4. And I'm coming up with 1.0518. Is that the same answer I gave you in the answer key? 1.05? There you go. Hey, guys, anybody remember, how do you find that 1.753 on your calculator? Inverse T, so we're going to go, I don't even have it on this one because it keeps erasing it. Okay, inverse t. That's right. Question? Question? Andres? Okay. All right, so look, guys. Second bars, right? Inverse t. I'm sorry, you said the area to the left was what, 0.05? Right, 0.05 because it's a 90%. And then we got to do our degrees freedom, which would have been what, 15? And go like that. And we're taking the positive one, right? So 1.75, so on and so forth, right? Okay, so guys, again, you can use your calculator. The one on my laptop, guys, every time I turn my laptop on and off, it takes out that little program that I put in there. So I got to type it every time. Yeah, I got tired of that. But anywho, that's how you'll do it on your calculator, right? The inverse t. All righty. Good deal. All right, any other questions on that same page? I think it goes to number 10. Any other questions on the same page? They're all very similar, right? Okay. What about on the next part, 11 through 14? Number 13. Okay, so number 13 now says construct a 95% confidence interval for the population mean mu. Assume the population has a normal distribution. A sample of 20 college students had annual earnings of 3120. And guys, like I said, when I came to the test, because it didn't tell me population standard deviation, this is assumed to be a sample. And what I did on the test, guys, on the actual test, I wrote the word sample there for you, okay? So you're not going to have a question about is this a population or is this a sample? You'll know exactly what it is, right? Okay, guys, do me another flavor. If you come back to the, let me see, your formula sheet one more time, okay? So look how we do our confidence interval, right? It's going to be x minus the error, x plus the error, right? That's still going to be my same confidence interval, whether I have my population standard deviation or my sample standard deviation, right? So let's first find our error. Okay, guys, I'm going to use the same formula that we used a little while ago. Okay, so let's see, our TC, we got to find our TC if we have a 95% confidence level. So guys, remember how we're doing this here? We're saying that the area on the inside is 0.95, right? So doesn't that give me 5% for the left and to the right? So what area would be over here? 0.025, very good. Guys, remember when you're doing this on your calculator, especially those of you who I programmed your calculators for you. When I programmed the calculators for you, doesn't the first thing say area to the what? To the left, right? So you're going to type in that 0.025. All right, guys, if my n in this case is 20, doesn't that mean that our degrees freedom is going to be 19? Okay, so remember, guys, the TC value we're going to be getting should be a positive one because we're really looking for that TC value. So what's the TC value with 0.025 degrees freedom 19? I know it comes up negative, but what's the positive one? Anybody do it? 2.09? Oh, you got 2.09? Did anybody else get 2.09? Yeah? Okay, guys, are we good on how we're coming up with 2.09? Okay, so let's double check. Let me see what happens. So remember, I'm not even doing that. I'm just trying to find my yeah, right? So guys, remember, we're going to go second, bars, inverse t. We said 0.025. And then our degrees freedom was what, 19? And let's see, 2.09, right? So we're going to use positive 2.09, right? So right here, guys, positive 2.09, okay? Times, what is our S in this case? 677 divided by the square root of what, 20? Okay, so let me take my calculator right here, turn it on, 2.09 times 677 equals divided by the square root of 20. And I'm coming up with 316 point, I'm going to say 39. Are we okay in how we came up with that number, guys? Don't everybody tell me at once. Okay, are we good how we got the number? Somebody said no. Okay, so notice what I did. I just took my calculator, 2.09 times 677, and then I divided by the square root of what? Sorry, it's a 20. Sorry, my handwriting's horrible. Square root of 20, right? And I can't. And the reason why I decided to write 316.39, isn't this telling me money? Right? Isn't the problem about money, guys? Okay, that's why I went to 39 cents, right? Because it's money. Okay, so now remember what we're going to do. The way we're going to find our interval, okay? Guys, the interval is always going to be x bar minus the error and x bar plus the error, right? Okay, so let's see. Everybody agree that in this problem, our x bar is equal to 3120? All right, so all I'm going to do is I'm going to take 3120 minus the error. The error came up to be $316.39. So I'm coming up with 2,803 and 61 cents over here. 2803.61. And then aren't we going to do the same thing, but instead of subtracting it, we're going to do what? We're going to add it, right? Let's come back over here and Adam and Eve. And let's see. 3436.39. 3436.39. What do you think? Seems okay so far? Tell me, Myra.
I was following the notes from the chapter and I followed the calculator right.
Uh-huh.
But I did step test,
Okay.
intervals, and then you enter the data.
Okay, so let's go like this. So guys, Myra said, look, we can do this also by going stat, right?
But it gave me the numbers were a little bit off, but I didn't do any.
Okay, let me ask you a question. Did you use z-test or t-test? T-test, right? How do we know we're going to do t-test, guys? Because of the S. Very good, right? So we come back over here, okay? We're going to enter in our stats, right? Okay. Oh, I'm sorry, t-interval. You're right. I'm sorry. My mistake. Let me quit. Okay, here we go. Stat, test. Here we go. T-interval. You're right. Number 8, I want to say it is. There we go. Okay, so now enter the data. Or let me see. Okay, my X bar. So we said our X bar was what, 3120? Let's see. Our S in this case was the 677. Okay. Our N, how many students were we looking at here? 20. And what's our confidence interval in this case? 0.95, so we don't got to change it. At least mine's already at 0.95. Calculate it. And let's see, it takes a little bit of time. Okay, so 22,803.2, 3436.8. Roughly the same kind of thing, right? It's just we're off a little bit by the decimals, guys. But again, this is perfectly fine. Guys, I'm going to ask you one thing. If you decide to use like the t-interval test, that kind of thing on your exam, just write down what it is you're doing. You know what I mean? Right? Just tell me you're saying, like, write down, I did t-interval, right? And when we did t-interval, let me go see if I can go back. Do it again. Well, I'm saying that on the test, it's going to say sample. The reason I knew it was sample is because it didn't say it was population. Right? That's how I know it was going to. That's how I knew from the beginning. If we were going to use this, we would have done whether I was going to do it sort of like by hand, like doing that, or whether I was going to use my calculator. I knew it was going to be a sample standard deviation because it didn't say it was a population, right? But on the test, I actually wrote the word sample for you and stuff like that. Okay, so you don't have to worry about that. So guys, if you were doing the problem like this on your test, right? T-interval, enter. All I would ask you is do me a favor, like label what's your X bar, label what's your S, right? Label your N. Just do that kind of stuff so that I know. So when I'm checking your answer, I can see, okay, well, so if Myra was doing this on her test, right? She wrote that stuff out, and then for whatever reason, you know, Myra, instead of doing T-interval, if you just happen to hit the wrong button and hit Z-interval or something like that, I would say, okay, well, I know what she knew what she was doing. It just happened to be the wrong button that she clicked, right?
That problem I did it Z-interval and it was wrong, but because I was using
The sigma, right?
Yeah.
Okay, so very good. So guys, I'm glad. So you heard what she said right now, right? She said when I did this the first time, I didn't do, yeah, I didn't do T interval. She actually ended up doing this one here, right? So look, if we do the same thing here, and we were to put our sigma, right? And we would have put our sigma, suppose we were to do 677, everything else would have been the same, right? And we were to check our answers, are we coming up with the same numbers? No, right? Look at the numbers we had here. I think when we did it on the calculator, instead of 0.61, we had like 0.20. And that was the only thing that was a little bit different, right? But look at these numbers. Are these numbers significantly different? Yeah, because we were off by some change, right? Now we're off by dollars, right? So I'm going to make this up, guys. If you would have done this, if this problem would have been on your exam, and you would have written out everything, you would say X bar is this, and you would write S is this, N is this, right? You'd write that stuff out. But you came up with this number out of 10 points, I'd probably give you 9. Because you're showing me you know what you're doing, you just happen to hit the wrong button. Does that make sense? Okay, so guys, again, you have two options on how you can do it. Either do the test or write it out, right? Whichever way is easier for you is fine with me. Well, so look at the problem that we did up here. What did number 7 tell me to do? So that we did it, right? You understand my point? So if I'm asking you to find the margin of error, find the margin of error, right? Did this problem here ask me to find a confidence interval? No, it didn't, right? It asked me to find the margin of error. What did I do? I used my formula sheet that I have right there for you, right? And it's a simple plug and chug type stuff, right? Good question. Guys, that was number 13. Anything else on that same page? We're good on that page? What about the following page? 15. Okay, so let's do 15. Okay, so guys, I'm going to do this. I'm going to clear this out. First thing I'm going to do, I'm going to go to stat. Guys, in this problem here, do you see how it gives us a table of values? Okay, so the first thing I'm going to do, I'm going to go to number 1. I'm going to go to edit. And okay, so guys, remember, if your list is not clear, clear your list. If you forgot how you clear a list, go up to where it says L1, hit clear, hit enter, and your list should be clear, right? Guys, all I'm going to do is I'm going to enter my numbers in. You agree the first number is 2? Okay, and then 3.2, 1.8, let's see, 2.9, 0.9, 4, 3.3, let's see, 2.9, 3.6, and 0.8. Okay, so guys, everybody agree we have 10 numbers there? Okay, I'm just going to make sure that I type them in right. 0.8, 3.6, 2.9, 3.3, 4.9, 2.9, 1.8, 3.2, and 2. Okay, guys, now what I'm going to do, I'm going to come back to stat. I'm going to go to calc. I'm going to calculate my one variable stats. So guys, again, on your calculator, it'll say one variable. You'll put right here, you're going to do your L1, depending on the way your calculator is set up. There you go. And then I know sometimes on some of your calculators, guys, it says frequency. You don't need to have anything on frequency. If your list 2 is empty, you can keep it as list 2. But if your list 2 has stuff in there, just delete the little L2 part on your thing. Okay, so let's take a look here. A couple of things I'm going to write, guys. I'm going to write down my X bar. So my X bar is what? 2.54? 2.54, okay. I'm going to look at a couple other things here. So let's see. Guys, I'm going to do my S in this case. My S is what? Yeah, 1.11. Okay. My N in this case is 10. And guys, y'all agree our C in this case is a 0.98? Okay, so check this out. If you want to use the calculator, you can go to stat. We're going to scroll over to tests. We're going to come back to that T interval test. Okay. Okay, guys, right here where it says you can either go data or you can go stats. Isn't it actually already putting all those numbers in there for me? Okay, the only thing I need to fix is which part. There you go. So right here, guys, let's go 0.98. Then we go to calculate. And as it's doing that, this was number 15, right? Okay, so guys, if you look at number 15 in the answer key, did we have 1.55 comma 3.53 on our answer key for number 15?
Yes.
Right? So I agree with Victor, guys. Look right here, 1.55, 3.53, right? And if we switch back over there, same numbers? There you go. What was the hardest part in that problem? Filling it in. All you got to do is enter the numbers in. Once you do that, boom, the rest of it just kind of does its thing, right? Good. Very good. Okay. All right, guys, any other problems on that same page there? Let's take a look at number 17. Okay. Let's see. 17 says a survey of 700 non-fatal accidents showed that 151 of them involved the use of a cell phone. Find a point estimate P for the population proportion of non-fatal accidents and that involve the use of a cell phone. Guys, all we're doing here, we're going to find our P hat. Okay, how many accidents did they survey? The total was 700, right? Okay, 700 accidents, right? Out of those 700, how many of them were on their phone when they got in an accident? That's all you're doing. Okay. So if we take our calculator and we go 151 divided by 700. Guys, if I go to, I don't know how many decimal places did I put on the answer key? 3? Okay, so did you put 0.216? There you go. Very good, 0.216. So guys, think about it this way. I mean, I'm glad Debbie asked me that question, right? And now, when we did our quiz today, right, when we did our group quiz, didn't we find P hat? That was the first thing we kind of did, right? So guys, it's a good question. I'm not going to put that question on the test, right? That's not a 10-point question. You know what I mean? That's like, okay, can you take one number and divide it by another and then you're done? But it's part of a question, right? So like when we did our quiz today, that was part of our question, right? So I'm glad that we did it, but I'm not going to ask you that question on the test, right? I'm trying to give you stuff, right? But I'm not going to give you that much stuff, right? I'm not San Nicolas. All right. Anyway, any other questions on the same page, guys? No? What about the next page? 20 through whatever it is, 25. Okay, 20. It says, a researcher at a major hospital wishes to estimate the proportion of adult population in the United States that has high blood pressure. How large of a sample is needed? Okay, so this is going to be the other one here. And you know what? Okay, give me 1 second. I didn't put that formula on the formula sheet, but I do have that formula on our notes. So give me 1 second. I don't know. I don't remember if it is or it isn't. But let's see. Guys, real quickly, if you do me a favor. Here we go. Where is it? That's the formula that I'm doing right here. Okay, so I'm going to write, this is number, which one you're asking me, W20? Okay, so I'm going to write the formula down here, guys, and then Q hat, CC over E squared. Okay, so guys, all I did here is I just wrote down that formula right there, okay? So let's see if we can answer some of these questions. Let me see. Okay, so guys, do you think we can find the ZC for being 99% confident? By that little table that's on the first page of our formula sheet, right? What's our ZC when it's 2.575, right? So that's going to be 2.575, okay? And let's see. The error is telling me that it's not going to be more than 6%. Guys, how would I write 6% as a decimal? 0.06, right? Okay. Guys, if you look at, I know I didn't, let me bring it back over here real quick. That's right. So guys, if it doesn't give me, here we go. Look what it says. Assuming you have point estimates, otherwise we're going to use P hat to be 0.5 and Q hat to be what? 0.5 as well, right? So all I'm going to do here, guys, is I'm going to go like this. I'm going to go 0.5 times 0.5 times 2.575 over 0.06 being squared, right? So what I'd probably do is I'd probably do what's on the inside of the parentheses first. Let me clear all this. 2.575 divided by 0.06 equals all that. We're going to square it. And then we're going to multiply it by 0.5. And then we're going to multiply it by another 0.5. And guys, I want to say that when I rounded this thing up, I rounded it up to 461. Right? Okay, and guys, I want to show you something here. Let me see. Look at the number I came up with, 460.4. I didn't round it to 461 because I said, oh, look, let me think of that 0.4 actually as a 0.5 because of this guy here. No matter what you get, 460 point, whether it's 0.9 or 0.0001, you always round up to the next one. You know what I mean? You're always rounding upward. Okay, so that's why I went 461. But you're probably right, Jordan. I probably didn't ask you that question on the test, but now we know how to do it, right? And so, guys, like that other question that we were trying to figure out earlier, number 13. When I did it, trying to use that other formula, I don't know why it wasn't coming out. Maybe my mistake could be when I did my own calculation, I just got it wrong. Okay, but I pretty much used a formula like that because it tells me that my error can't be more than what, 6%. So isn't 6% as a decimal 0.06? Huh? Huh?
I don't see where it says it can be more.
Because it tells me right here, it says that the sample proportion will not differ from the true proportion by more than 6%, right? No, but she's talking about how did I come up with 0.06 right here. And the way I come up with that is because that's going to be my error. It's telling me that the sample proportion will not differ, which is my error, from the true proportion by more than 6%. As a decimal, 6% is 0.06. That's what the error is telling me, right? Okay, so but look at 21. So guys, if you look at 21, is it asking me for a formula or anything like that? No. No, right? Oops, sorry. That's right. That's right. So 21 is just saying, look, the mean average of bus drivers is 51.8 years. State the claim mathematically. So guys, wouldn't I say mu is equal to 51.8? And wouldn't that be our what? Our HO, very good. So then this is going to be my HO. So then our HA is going to be that it's what? Not equal to 51.8, right? That's all you're doing for those, right? Yeah, what number was that? That was 21, right? So 22 is the same, 23 is the same, 24, Gassi the same, right?
For number 23?
Okay, so guys, let's take a look at number 23. Let's see. The mean score for NBA games during the season was less than 94 point games. Okay, so we're still talking about mean score, right? So mu is going to be less than what? 94? Isn't this my claim? So is that my HO or my HA? That's my HA. Very good, guys. So then wouldn't my HO be that mu is going to be greater than or equal to 94? Victor, am I making sense?
Well, because I got, on the first one I got less than or equal to, because I thought we were counting the 94 less.
No, because look what it's going to be real specific, right? It says it's what? Less than 94 points a game, right? So if it would have said less, if we were going to put the equal to, and it would have said less than or equal to. Yeah. Good question, good question. So guys, 24, very similar, right? 25. So look what it says here. A researcher claims that 65% of voters favor gun control. Okay, so guys, do you see how this is giving me a percent? So that's telling me that my P is equal to what number? 0.65. Okay, that's my claim. Right? Or 65, I'm sorry. 65. Okay, so is this, everybody agree that's our HO? So then our HA, wouldn't our HA be that it's what? Not equal to 0.65? Okay, and then look what the question says. The question says, determine whether the hypothesis is left-tailed, right-tailed, or two-tailed. What would it have been? It's going to be very good. So guys, what Rafael says, look, this is going to be on my HA, and because it's not equal to, it has to be a what? A two-tailed test.
So it says at least, is that equal to?
So you're talking about this one here? Okay, so number 26 is what you're talking about? Right, like the next one, the one that we just did?
Yeah, that's the same.
Okay, so 26 says, look, a brewery claims that the mean amount, right, so there was my mu, is at least 12 ounces, right? So guys, remember what at least 12 ounces means? Greater than or equal to, right? At least 12 ounces means it's 12 ounces or what? Or more, right? Okay, so this is our claim. Is that my HO or my HA? That's our HO, right? So then wouldn't our HA be that mu is less than 12? Okay, so guys, Rafael says we're going to look at our HA. Left tail, right tail, two tail test. Left tail test, boom. Why left? Because it's going to the left. All right. Any other questions, guys? Let's see. What this is number 27. Okay. Anything else on that same page? 27 through, I don't know, 32. 31. Let's look at 31. Okay. So it says the p-value for a hypothesis test is p is equal to 0.066. Okay. Do you reject or fail to reject the HO when the alpha is 0.05? Guys, I want y'all to do me a favor. If you look at the formula sheet, let me see, do I have it? Here we go. Yes. So on the second part of the formula sheet, guys, do you see right here it says decision based on a p-value? It's on the second page of the like the back page of the formula sheet. I'm looking at this part right here. So if p is smaller than alpha, then we're going to reject it. If p is greater than alpha, we're going to fail to reject it, right? So look at my p number. My p number here is 0.066, right? And my alpha is 0.05. Guys, think about this in terms of money. That's a little bit, it's a little bit more than 6 cents. And this is exactly, what, 5 cents? Okay, which one, this is my P, right? And that's my alpha. Is P bigger than alpha or smaller than alpha? P is bigger than alpha, right? So guys, when I look at that formula sheet, right? And I look at my formula sheet, if P is bigger than alpha, what are we going to do? Fail to reject it, right? So I'm going to come back over here, and we're going to say we fail to reject it, right? Did that make sense? And it's just looking at that little piece right there. All right. Anything else on that same page, guys? Okay, what about the next page, which looks like it is 33 through 39? Which one? 30? 35? Okay. To test the claim. All right, so let's take a look here. I'm sorry? 33. Okay, let's do 33 and we'll come back and do 35. Okay. To test a claim, or test a claim about the population me at significance alpha, assume the population is normally distributed. Okay. So guys, look, they're already kind of giving me some information here. Okay, so they're saying that mu is greater than 22, which is our claim. Is that my HO or is that my HA? That's our HA, right? Okay. So our HO is going to be that mu is less than or equal to 22. Okay. Let's see, what else do we know? We know that our alpha in this case is 0.05. Okay. And we know that, let's see, we know X bar is 22.3. We know that sigma is 1.2. And we know that N is 50. Okay, so guys, remember when we're finding this piece right here, which is on that same page, right? I'm just using that formula sheet. Remember, I did not label them formula like 1, 2, and 3, right? So guys, look at the formula that I'm writing out. Am I using formula 1, 2, or 3? Number 1, right? Okay. So let's do number 1. Let's see. 22.3 minus 22. Let's see. Sigma is 1.2. Oops. It's a messy 1.2. 1.2 divided by the square root of 50. Okay. All right, so guys, I'm just going to grab my calculator right here. Turn it on, clear it out. Okay, so 22.3 minus 22 is, and then divided by, I'm going to put all this stuff in parentheses, right? 1.2 divided by the square root of, what do we say, 50? And close it. Okay. So guys, the z value that I'm coming up with here is what, 1.77? If I go to 2 decimal places? So far, so good? Are we okay in what we did so far, guys? I just want to make sure we're all good. Yeah, we're good? Okay. So 1.77, right? Okay. I want you to think about this for a minute. Okay. So right now, our alpha is 0.05, right? We came up with, guys, with a z value of, what, 1.77? So what I want to do is I want to figure out what's my probability, right? What's the area here, okay? So guys, if I want to find the area over there, wouldn't I go second bars? Wouldn't I go normal CDF? And guys, look, if I'm going to go here all the way to 1.77, what's the first number I should enter in of them all the way over here? Anybody remember? Yeah, negative all the 9s, right? So we're going to go negative, oh, a bunch of 9s, okay? And then we're going to go comma, 1.77, okay? Okay, so look at the p-value I'm coming up with. The p-value I'm coming up with is 0.96. P equals 0.96. All I'm going to do again, guys, I'm going to come back to my formula sheet one more time. Look what it says. If p is smaller than alpha, we're going to reject it. If p is bigger than alpha, we're going to what? Fail to reject it, okay? So was our p number bigger or smaller than alpha? Bigger, right? Think about it, guys, 96 cents and a nickel. 96 cents is bigger, right? So since p is greater than alpha, we're going to what? What does it say to do? Look at the formula sheet again. Fail to reject it, right?
That's wrong.
I didn't put that? Oh, I came up with a different p?
Because what you did was the stats and the details.
Let me see. What number was this again? I'm sorry? 33. Let's see. And I came up with p to be what? 0.325? 0.385? Let me see. Maybe I did something wrong. Hold on. Oh, is that what I did? Okay. Ah, that's right. Okay, my bad. My mistake. There we go. My mistake. Okay, I didn't even think about that. You're right. Oops. Okay. Sorry. Okay. So our alpha here is 0.05, right? So isn't the area over here 0.95, right? Okay. Let's see. And let me see here. Yeah, but I'm trying to figure out, give me 1 second, guys. Where's my calculator? Here we go. When I did the, let's see, second bars, let's go like this. What did I say? Normal CDF, right? I went like that. And then we say the negative, all the 9s, right? Comma. And then I stopped at what, 1.77? Okay. Let's see, 0.96. So yeah, think about it this way, guys. If this is 0.95, right? And the value that I'm coming up with the p is 0.96, isn't this one here what? This would fall over here? Y'all agree with that? If this is 0.95, wouldn't 0.96 be a little bit more in this range? Does that make sense?
So that's not the P you got.
I know, but let me see, because I'm trying to figure out how did I come up with my p-value.
There,
It's a
I
Z
followed
test.
what
I did the z-test, so I went stat,
I put stats,
z-test, and then did we go stats? And right here we typed in 22. And let's see, we typed in for sigma, we typed in what? Point, I'm sorry, what was it again?
1.2.
1.2? Sorry guys, I'm just trying to move this over. Let's see, 1.2, 1.2. And let's see, our X bar was 22.3. And my N was 50. And this is left tail, right tail, two tail. Right tail, this is right tail, right? Enter, and then calculate. And there we go. Okay, so I'm trying to figure out why I came up with something different. Right, but because you know what I'm trying to figure out here? Give me 1 second. Yes, okay, okay. All right, you know where I know where I'm making a mistake, guys. Okay, so do you see how I'm coming up with a 0.96 right here? Right? My P in this case is not the area to the left. My P in this case is going to be the area to the right. So, guys, think about it. I'm sorry about that, guys. I've another little brain fart here. But look, if I were to go 1 minus 0.96, what's 1 minus 0.96? 0.04? Okay, when we did our stat and we did our z-test, right? Right here, and we did everything here, and I hit calculate. Isn't this number here, if I were to round it to 2 decimal places, wouldn't it be 0.04? Okay, because I was making my mistake. I was doing my area to the left, and my P is really going to be the area that way, right? So the way I could find that area that way, if I were to have done all this business here, I still would have come up with 1.77, right? The only thing I would have done different is when I would go second bars and I do my normal CDF, right? I'm going to start from this point and go that way. So I'll be going 1.77, comma. If I'm going to go all the way over here, wouldn't that be all the positive nines? Right? And look, isn't it the same number? Right? That's all it is. Okay, that's where I made my mistake. I'm sorry, guys. And then from here, let's see. What do we say we're going to do? We're going to reject it? Reject the HO, right? There we go. We're going to reject the HO. And I think it's all it's asking us to do, right? It was all it's asking us to do. And I don't know, did we write? I didn't write anything else, did I? Right. And isn't that the same number that I came up with here? Right? There you go. So guys, that was my mistake. When I came up with my z-value, the z-value is still the right z-value. It's just when I did my normal CDF, I was doing this, and I needed to go, since it was a right tail test, I needed to go from 1.77 all the way to the right, and that's why my P is coming out like this. Right, so the P is less than alpha, right? And what do we say if the P is less than alpha? Then we reject it, right? So if the P is less than alpha, then we reject it. Right. That's all it is. Okay, let's see. Guys, do we have, are y'all cool with you? We go to 37? Okay, let's go to 37. Okay, let's do 37, and we'll come back and do 35, because 37 is going to be very much the same way, right? So look, let's do 37. Let's see, a local brewery distributes beer in bottles labeled 12 ounces. A government agency thinks the brewery is cheating the customers. The agency selects 50 of these bottles. Okay, so guys, y'all agree so far that N is 50? Okay. Measure their contents, and it obtains a sample mean of 11.11 ounces. So that's telling me that my X bar is equal to 11.7. And look what it also tells me. A population standard deviation of, what, 0.70? Okay. Use a .01 significant level to test the agency's claim that the brewery is cheating its customers. Okay. So alpha here is .01. All right. So let me see if I can do something like this. Okay. So guys, let's figure out what they're saying. What's the claim? A government agency thinks, oh, right here. A local brewery distributes bottles that is labeled what? So isn't their mu supposed to be equal to 12? So wouldn't this be my claim? Right? Is that going to be my HO? So this was number what, 37? I put less than, right? Let's see. You know why I put less than? Because what is the government agency saying? They're cheating their customers, right? So they're cheating their customers. It's not going to be equal to, it's going to be what? Yes, it's going to be less than. Okay, so that's actually going to be my what? My HA, right? Okay. So then wouldn't my HO be that mu is going to be greater than or equal to 12? Okay. All right. So now, let's see. Guys, I'm just going to write over here on the side. Okay, so let's think about this for a minute. Look at my HA. Left tail, right tail, two tail test. Left tail test, okay? So look, my alpha here, 0.01. Guys, could we find that critical value ZC? Kind of like what we did on the quiz on Tuesday night and what we did today. How would I find my critical value? You go to the chart. Can I go inverse norm? Okay, what number am I going to type in? 0.01, right? Okay. 2.33, negative? Okay, so negative 2.33, right? Negative 2.33, okay? Guys, can we find our Z value using this right here? Okay. All right. So what was our X bar in this case? 11.7. So I'm going to go 11.7 minus 12 divided by, what was our sigma? 0.70 divided by the square root of, what was our N? Square root of 50. Right? Okay. So let me take my calculator and let's do this. So we're going to go 11.7 minus 12 equals negative 0.3 divided by, I'm going to put this in parentheses, guys, 0.70 divided by the square root of 50. And let's see, I'm coming up here with a negative 3.03. Okay, so guys, think about this for a minute. Okay, that is the negative 2.33, right? Negative 3.03, would that be, remember this is my reject and this is my fail to reject. This is going to be in our rejection reason, right? Okay, so what are we going to do? Are we going to reject the claim? We're going to reject, we're going to reject the null, right? So we're going to say, we're going to reject the HO, right? And then guys, I'm going to just kind of come back over here. What was our claim? My claim was the which one? The claim was the HA, right? So if I come back to that formula sheet, right? Here we go. So my claim is my HA and we're rejecting it. Aren't we going to say there is enough evidence to what? To support the claim? Okay, is that what I wrote in the answer? Boom, there we go. Apparently I did it right that day. Yeah, so guys, I want to say that when I was doing the answer key, I think I did a bunch of them doing the P, right? But let me ask you a question. As we're going through, like, look at how we did this problem here. Didn't we do this problem the same way we did the quiz on Tuesday and the quiz today? Okay, to me, this seems a little easier than going through the P stuff. Does that make sense? So guys, the way I set up remember like I told you, the way I set up the test is almost identical to the way I set up the quiz, right? So we look at the quiz like we did today. Let's see, it should be here somewhere. So look, this is how I set up every one of the questions on your test, right? This could be question number 1, and then it's going to go like that, right? And then question number 2, they're all going to be set up this way. So to answer Anna's question about do we have to do the P, I made the P one the bonus question, where you have to do it using the P way. Does that make sense? Right? So doing it using the P values like the way I using the P way, right? The way I did it here on the chart on your answer key, that's what I'm going to ask you to do. Okay? So look, let's go through that. Let's suppose we were going to do the same problem, right? And suppose we're going to do it with those P values. Okay. What I'm going to do, I'm going to kind of shift this up a little bit. Okay. All right. The only thing that's going to be different, guys, if I use the P values is y'all agreed that our alpha was 0.01? Okay. So we already knew the alpha to be 0.01. When we did our work right here, we came up with our z value to be what? Negative 3.03? Okay. Was this a left tail, right tail, or two tail test? This is a left tail test. Okay. So guys, what we're really trying to figure out here is that if 3.03, I'm trying to find that area to the left because this is a left tail test. So if I'm trying to find the area to my left, I'm going to go second bars. I'm going to go normal CDF. Okay. Guys, if I'm trying to find the area over here, what's the numbers that are all the way this way? The negative with all the nines, right? Okay. And then I'm going to stop at negative 3.03. All right. What's the p-value that we came up with here? If I were to go to, say, 3 decimal places, because I know 2 decimal places ain't going to help me a whole lot. 0.00 what? Is it 0.001? Right? If I just come back here, guys, take a look here. 0.001 is my P? Okay. Then remember what we said we're going to do? We're going to do a little comparison. We're going to come right here. Okay. Is P smaller or bigger than alpha? Look at the P value. Here's the P. Here's the alpha. P is smaller. So if it's smaller, what are we going to do when P is smaller? We're going to what? We're going to reject it, right? So isn't that what we said we're going to do? That we were... Didn't we say we were rejecting because look at when we did it earlier, we fell in that rejection range, right? Guys, the problems are in essence the same thing. What you're doing when you're doing the rejection regions is you're comparing your your critical value with your test statistic. And you're just saying, does it fall in this range or does it fall in that range? When you're doing the p-values, you're comparing the area. Is this area bigger or smaller than this area here? That's all it is you're doing. You're either looking at the z-value or you're looking at the area under the curve. But in essence, it's the same sort of concept, right? It's just which way do you look at it? I don't know if that made any sense or not. I hope it did. But I set up, long story short, guys, I set up all the problems to be something more like this, right? And the bonus one is the one who I'm asking you to find the p-values, right? Okay. Somebody asked me, that was number 37, but I know Debbie was 35? Was somebody asking me 35? 35? Okay, test the claim, so let's see. Okay, so right here, I'm just going to write, I didn't give you guys a whole lot of room, guys. Bye-bye. I apologize for that. But U is greater than what, 29? So everybody agree that's our HA? Okay, and then so mu is less than or equal to 29. That's going to be our HO. Okay, guys, left tail, right tail, two tail test. What do you think? Right tail, right? How do we know it's going to be right tail? Because we look at the HA, right? Okay, so guys, I'm going to do this using the rejection region, kind of like what we did in our quiz, because I just think it happens to be a little easier. All right, does it give me a value for alpha? For number 35? 0.05, right? Okay. So my alpha here, this is alpha, it's 0.05. Guys, if I wanted to find that critical value there, remember when I'm doing this on my calculator, when I'm going to do my critical value, whether I use my inverse norm or whatever I'm using, remember that always tells me the area which way? To the left. So the area over here is 0.05, what would the area to the left be? 0.95, right? Good, so let's go second bars. Let's go inverse norm. We said the area to the left is 0.95. Enter. So my z value is going to be positive here. 1.64. Okay. So let's write here 1.64. Okay. Guys, everybody agree that this is my rejection region and this is my fail to reject region? So far, so good? Okay. So let's see what we can figure out. Guys, I'm going to find my z-value, okay? My test statistic. I'm going to go like this. X bar minus mu divided by sigma square root of n. So my x bar in this case is what? 29.3 minus 29 divided by sigma in this case was 1.2 divided by the square root of n, which was 50. Okay. So again, guys, I'm going to grab my calculator right here, move it over here to the side so I can do that. Y'all can see it. Let's clear this out. 2.90 or 29.3 minus 29 is 0.3. Okay, divided by parentheses 1.2 divided by the square root of 50. And for my z-value, I'm coming up with 1.77. Okay. So guys, think about that number, 1.77. Would 1.77 fall in the fail to reject or in the rejection region? It would fall in the rejection region, right? So aren't we going to say now that we're going to, we're going to reject the null? It's always reject the, either fail to reject or reject. It's always the HO, guys, okay? And then we have to go back and say, okay, what was the claim here? The claim was actually our H what? Yeah, the claim was our HA, right? And because we rejected the null, here we go, yeah, because we rejected the null and our claim was our HA, we're going to say what? There's enough evidence to support the claim. And again, guys, that was for number 30, what, 5? 35. Alrighty, so let me see. What's number 35? Let's see. So guys, we did 35, we did 37. Right, because I did it using the p-values, right? But like, what did I just say a little while ago? Which way was easier? To me, the finding the rejection regions is easier, right? Right. Well, what I'm going to ask you though. Think about it this way. Hold on, but I want you to think about it this way. The way the questions are going to be worded on the exam are very similar to the way I worded these, right? So my thing is, did you feel like you did okay on Tuesday night's quiz? You felt like you could follow that. The critical value parts. Okay. What about tonight's quiz? Okay, because you had a little bit more practice, right? So again, I set up all the problems exactly like this, guys. I know that when I wrote my answers, I did a lot using the P's and the alphas, but to me, like the rejection region. So, like, do me a favor. If you look at the answer page for problems like 40, 41. Right, 40, 43. I set them more up like this. Does that make sense? That's how I set them up. Like I said, the one that I'm going to ask you to do the alpha, that'll be your bonus question, right? But the rest of them I'm going to ask you set it up like this, right? I'm asking you to set them up like that, right? There's only going to be one where you got to do the alpha. That'll be your bonus question. If you know how to do the alpha, great. But I'm asking you to do other ones like this. All right, let's see. Let me come back to this business here. Guys, any other questions on the review that you want me to take a look at? Is there any other questions you want me to do? So we already did one, we already did on that page, we stopped at, or the last one we did was what, 37? Okay. Guys, any questions from 40 through 47? I'll tell you what, guys, let's do 42. Let's do 42, and the reason why I want to do 42, so didn't we do, what was it, 37? Okay, so look at 37, guys, and look at 42. What's the only difference in this problem? Anybody know? What's the difference between 37 and 42? Like if I look at 37, right? Here's 37. I'll give you a hint. There you go. There's one small difference right here. What did 37 gave me what? Population standard deviation? And this one here, if it doesn't tell me, it's going to be the sample, right? Like I said, guys, on the test, I actually wrote the word sample for you, so you don't even got to figure that part out, right? But this is going to be sample, right? But let me ask you a question. Are all the other pieces of information the same? Okay, so remember when we did this problem, look what we said. The government agency thinks that they're what? Okay, so doesn't that tell me that the mu, according to the government agency, is going to be less than 12? Okay, this is my claim, right? Okay. So then the complement is going to be that it's what? Greater than or equal to 12? Okay, guys, everybody agree this is our HA and our HO? Okay, so that part's good. That part's good. Okay, guys, like I said, I'm setting this up just like the way the quiz was set up today, right? So look, if we were doing this problem, right, for the quiz, I'm curious if it lets me do this here too. I guess it does, right? So forget about, oh wow, cool. Forget about all that, right? So the claim, we're saying that the claim mu is less than what, 12? Okay, so right here I'm going to go mu is less than 12, and so that the null is, the HO is going to be greater than or equal to 12, right? Okay. Now it's asking me, find the critical values and identify the rejection regions. Use alpha to find the critical. Okay, so in our problem, guys, on 37 or 40, whatever one it is, 42, what's the alpha they gave me here? 0.01, right? Use a 0.01, so that's my alpha, right? Okay, so guys, I'm just doing this kind of like, you know, the same kind of thing here. So my alpha here is 0.01. Now, did we say left tail, right tail, or two tail? It's a left tail, right? Okay. So if my alpha is 0.01, how do I find, I got to be able to find that value there, right? Now, guys, remember in this particular problem, we don't know the what? Do we know the sample standard deviation or do we know the population? Yeah, we know the S, right? So look, let's write down a couple of pieces of information, right? So look, let's do this. Look, X bar, isn't X bar equal to 11.7? Right? Isn't my S going to be 0.7? Okay. What is my N going to be here? N's going to be 20, right? Okay. So guys, the first thing I need to figure out is, give me 1 second. Oh, let's see. We got to find our critical value for the T part. So how did we find our critical value for the T part? Trying to see if I have my notes again. Here we go. Inverse T, right? Isn't that how we did that? There you go, right? That's how we're going to find it, right? We're going to go inverse T. Okay. So let's see. Yeah, let me come back here. Let's see. Okay. So this is left tail test, right? I got to do it on this thing here, guys, because on my calculator, it already went away. Okay, so inverse T, what do we say the area to the left was? 0.01, right? So I'm going to go inverse T here, 0.01, okay, and then we got to go comma, degrees freedom. Guys, in this particular problem, that's right, very good, guys. So in that problem, since my N was 20, our degrees freedom is going to be one less, 19? Okay, boom. Okay, are y'all coming up with something like negative 2.54? Okay, so I'm going to do this real quick, guys. Let me come back here. I'm just kind of trying to do it in the same format. So right here, this is going to be negative 2.54. Guys, everybody agree this is reject and this is fail to reject? Okay. The only thing is going to be, so guys, if this problem was on my test, right here where it says find a standardized test statistic, it wouldn't say Z, it would say T, right? So yeah, so I want you to do me a favor. Look at your formula sheet, right? On the very first page here. You know how we have formula 1, formula 2, formula 3? Which one do you think I'm going to use? Number 2. Okay, so look guys, we're going to write x bar minus mu divided by s over the square root of n. Okay, right? All right, so what was our x bar in this problem anyway? Was it 11 point something or another? 11.7, right? So we'll come back over here, boom, 11.7 minus the mu was 12. Okay, my s in this case was it 0.7? 0.7, good. Okay, 0.7 divided by the square root of 20. Okay, so look, let's take our calculator. Okay, so 11.7 minus 12 equals divided by, put all that stuff in parentheses, 0.7 divided by the square root of what, 20? Okay, and so guys, look what I'm coming up with, negative 1.982. Okay, question guys, negative 1.92. Where would that fall here? Negative 1.92. Would it be to the left or would it be to the right? That's right. It would be somewhere over here. So we're going to say we're going to fail to reject the null hypothesis, right? Okay. Guys, let me come back over here. Was my claim my HO or was my claim my HA? My claim was my HA, right? So if I look at my formula sheet, so my claim is my HA and we fail to reject, we're going to say what? There's not enough evidence to support the claim? Yes, thank you so much for letting me know. Boom. Guys, so let me ask you a question. Do you see the only thing we did different from, this was what number again? I'm sorry. This is number 42, right? The only thing we did different from 42 to, what was the other one? 30, was it 37? Was in 37, when we did 37 over here, look at the critical value we came up with. We came up with a negative 2.33, right? And then when we did it right now, our critical value was a negative 2 point what? 54, right? And then, let me see. When we did our test statistics, we came up with a negative what? 3.03. And when we did this one here, we came up with a negative 1.92. But isn't the process exactly the same? It's just that, am I using formula 1, formula 2, formula 3, right? And then how do I find this number here? I'm either going to go inverse norm, or in this case we did what? Inverse t? Does that make sense? Yeah? You sure? Everybody's a little quiet. I'm just trying to make sure we're good, guys. Okay. Yeah, and I honestly, guys, I think what it is when I made the review, at that point, I think we had done a lot of the P testing and alpha testing, so I just did them that way. And then once we went through the critical values and the fail to reject regions and fail to reject regions, and that's how Tuesday's quiz was set up and tonight's quiz was set up, and it was like, you guys really seem to be, for the most part, everybody seemed to be kind of really hitting it. That's why I decided to go that way, because I didn't want to, I know I wrote the answers in a particular way, but let me ask you a question. Like this was, the one we just did right now was number what, 42? So I look at 42, right? We said we're gonna fail to reject the null hypothesis, and we said there is not enough evidence, right? And if I look at my answer key, actually, didn't we do this one exactly the same way? Right? All right, take care. We actually, the way I wrote the answer to this one was actually the same way, right, that we did it here. But my whole point was that you guys, based on what you did Tuesday and what y'all did tonight, y'all seem to really be hitting this idea really well. And that's why I decided to make the questions more like this.
So basically, we could go through all of this using
The rejection,
the 3 formulas
yes.
and just not go with your P.
You don't have to do the P answer. So think about it this way. The only thing that's different, so guys, if I look at my answer key here, right? In this case, wasn't our alpha here to be, what was it, 0.01? That was the alpha they gave me? Okay. If we would have done, instead of me finding that number right there, if I wanted to find the area under the curve, given this sort of t value, I'm trying to remember if I can remember how to do it right now. Give me 1 second, turn it on. Second bars. Yeah, we actually didn't use this formula, but I would have used, I know, like, think about it this way. If instead of a TC, suppose those were Z values, right? Suppose those were Z values. And I already knew that my alpha was 0.1. If this was a Z value for negative 1.97, I would have gone normal CDF, and I would say negative all the 9s, right, up to negative 917, right? And enter, right? And I would have compared the p value, which in this case would have been 0.0, right? I'm rounding this to 2 decimal places, 0.03. I'm going to compare that to this one here, and I'm going to say, is p bigger or smaller than alpha? That's really the difference between the two.
So P's just one more additional step.
Well, it's not necessarily one more additional step, because you know what? If I would have done that, I would not have found that value right here. I would have skipped this step
Yeah.
and found that step instead.
You skip that. I followed the notes from the review
From the homework, like the notes?
homework and the notes, and I did to testify, I did step, test, retest, enter the data,
Which you already have there, right?
You get the X bar, the S, the whatever, and then it gives you the two,
And you compare them, right?
and you compare them
To the little alpha, right?
Yeah, the alpha.
There you go.
So that, and then you use this.
If p is bigger than alpha,
The P is bigger than that. That's how I did it.
Yeah.
That's why, like, you were looking for the V and all that, I was like,
yeah. But that's how I set it up. So the only thing is you're doing different is that when you're doing the p test or you're using the p values, you're not going, let me do inverse norm to find that. You're not even doing that step. But once you find this z value, you find the area based on that z value there, and then you kind of take it from that point and you compare the two. So it's the one that we did right here,
like how
the rejection, the failed to reject.
the way you're setting it up is
I'm setting it up that way because to me, you're doing it in pieces, right? You know what I mean? Like, did you find this? Yes. Did you find this? Yes. You can do it in little stages. Not that the other one isn't good, but I think the other one we sort of miss. Well, what am I doing?
right.
Other than, you know what I mean? Like, I'm just comparing these two numbers and then I'm just going to go with that.
I was just mentioning
That's right. And that's kind of why I liked setting up. Let me see. I'm just going to pull up another one real quick, guys. Oops. Yeah, let me see. Why is it like this now? Maybe because I did that. There we go. So, so guys, again, I set it up. You know, I'm gonna hit pause on this thing. Otherwise, this video is already an hour.